Hi, my name is Tovio Roberts, and this is another Latent Topics in Data Science. I'm going to do something a little different today. Last week I mentioned that today I might extend some stuff around digital image processing, and I have this whole project that I'm going to live stream next time. But I decided that I'm just going to kind of take you through some CodeWars stuff. We have a couple premium prep courses starting right now, and it's kind of a good time for those students to see how to solve some simple problems on CodeWars. There are other sites that fill this function that CodeWars fills of, basically giving you things that you can do repetition on, right? Like anything, you're kind of working out these approaches, learning the language, and repetition is, it's going to help you. So, I figured I would just spend 45 minutes or an hour solving CodeWars problems and kind of talking through them, and mostly doing really, really simple ones. So, what is CodeWars? CodeWars is this site that has a bunch of community-built problems that you can solve with code. And we're going to solve a few of those in a few minutes. But let's kind of just take a quick overview of this. If I go to, I'll just open up a browser window and go to CodeWars. Notice when you get here, the first thing it's going to ask you to do, let's say, is sign up. And maybe I'm going to click on Python because that's what I'm interested in. And it's going to ask me, hey, try to figure out why this function doesn't work. So it gives you this sort of gate to get in. Now, if you don't know what functions are, this is going to be hard to solve. And if this is your first time on CodeWars and you're really new to Python, well, this might actually be a strong gate. But I'm just going to show you how to solve this. It's really straightforward. Hopefully I'm not breaking any terms of service or anything by doing this. I probably am, but this is a multiply function. It's going to multiply A and B. And what was here was this kind of just this, right? So it's multiplying A times B, but it's not returning it. And functions are generally meant to return something. So I'm just fixing that. Returning A times B, I'm going to submit it. And it goes ahead and it passes these tests, and then I would click on enlist and go through the registration process. So pretty straightforward, pretty easy. And the way that I got here into this interface, there's this sort of side menu here, and there's home. There's this thing that says kata. Kata are just problems that you can do, essentially. And this is kind of a whole theme around this whole martial arts theme. And, if I click on kata, it's giving me this, 6,000 something kata found. And you can see there's these difficulty rankings on the left. And I'm going to go ahead and do the easiest, which is not 1, it's 8. And I'm going to limit this by just 8. And there are 450 now. But I don't have this sort of narrowed by language, and I'm going to go ahead and do that. I'm going to narrow this to just Python over here. So language, Python. And I'm going to change the sorting. I just think this is nicer. I'm going to sort it by popularity, and this is going to, the most popular problems, total times this kata has been completed, something like 3 million times. That kind of indicates that the kata can be completed, most likely. A lot of people have seen it, and if there are bugs in it, those bugs have probably been resolved. So I'm just limiting this to problems that are likely able to be resolved. And I'm going to go ahead and also change this progress to kata I have not completed yet. And this is just like a simple workflow for me to do repetitions on here. So there's this 8Q Caillou, Q, I'm not sure how to pronounce that. Could probably look it up. Problem called regular ball, super ball. And I'm going to right click on this. And I'm going to open this link in a new tab. And, oh, this is actually using objects and object-oriented programming. So I'm going to skip this one. Why don't we look at a different one? Find the difference in age between oldest and youngest family members. So let's do that one instead. And this is going to give me a description. I can read this here, or I can just click train. And it looks like I'll be given an array of all the family members' ages. And by array, they mean Python list, I'm assuming. The ages will be given in whole numbers, so a baby of 5 months will have an age of 0. Return a new array with youngest age, oldest age, and difference between the youngest and oldest ages. That looks like a list to me with 3 values. So I'm going to click on train, and we can go ahead and try to solve this. All right, so the first thing I'm going to do here is look at the tests. And that's generally going to be your best bet in trying to figure out these kinds of problems. I'm also going to just adjust this a little bit so you get, maybe I'll make this a little bit bigger. It doesn't get too crunched up. Yeah, let's go with that. I think that'll be fine. Yeah. All right, so difference in ages. And these are ages in months. Oh, yeah. No, these are in years. All right, so I'm going to take the youngest and the oldest. Youngest age, oldest age, and the difference. And looking at this, this is the Python list here that's getting passed in, right? So this is getting passed into our function, def differences in ages, and this is what we're going to be going through. So what I can do here is there are these, built-in functions in Python that are really convenient for this kind of thing. So I'm just going to make something called youngest, and I'm going to get the min. So this is the min function, and I'm going to get the oldest, and that's going to be the max from ages. And then it's asking me to return a list, I think. Oh, nope. It's asking me to return a tuple. This is a tuple, if you haven't seen it before. It's surrounded in parentheses. So this is going to be youngest, oldest, and difference, which is just the oldest minus the youngest. So I can return a tuple that looks like this. This is going to be youngest, oldest, and oldest minus youngest. So if I click test down here, it's going to give me some output over here. And notice I'm passing all the tests. So if you click test, it's only testing what's in this area right here. These are all unit tests that have been written. And this is kind of a nice way to start learning what unit tests look like, right? And essentially this is saying, is this function call right here, it's asking, is this function call equal to this output? And in this case, it turns out it is. So what I'm also going to do here, I passed the tests, but I'm going to just make this function a little more compact, which is something I can do if I just replace youngest with min of ages, and I can replace oldest with max of ages, and then I can replace oldest minus youngest with min of ages minus max of ages. And that should just work. And I already tested it once. I could test it again, but I don't think I need to. I can click attempt, and this will run it through a whole bunch more tests. Oh, oops. I need to do max minus min, not min minus max. Which maybe some of you noticed. And I passed all these tests. Now, when I hit that attempt button on the right, it is going to run it through a whole bunch of tests I haven't seen yet. And this is where CodeWars can be a bit buggy at times. Because those tests aren't exposed, it's going to be hard sometimes to figure out how to pass them. But I did pass all these, and we'll probably run into something like this in a little bit. So I submit this, and then it gives me other people's solutions as well. So notice there isn't just one solution here, although this solution looks exactly like the solution I just put in. But yeah, there's a bunch of other potential solutions, and that's fine. So yeah, it gives you a chance to improve your code through the lens of other people's coding. And sometimes other people's snippets of code won't be preferable to you, and that's fine as well. Okay. So I just closed that outer window, and we did this problem. I'm going to go ahead and reload. And because I have this only showing the kata I have not completed, it got rid of that one I just did. So that's kind of my practice workflow. So let's do what's the real floor. Okay. And the description here is Americans are odd people in their buildings. The first floor is actually the ground floor, and there is no 13th floor due to superstition. So write a function that, given a floor in the American system, returns the floor in the European system. Okay. I guess the European system starts at 0 and includes a 13th floor. So with the first floor being replaced by the ground floor and the 13th floor being removed, the numbers move down to take their place. In case of above 13, they move down by 2 because there are 2 omitted numbers below them. Okay, so given a floor in the American system, returns the floor in the European system. Okay, so if it's the first floor, it's actually the 0th floor. If it's the 5th floor, it's the 4th floor. If it's the 15th floor in the American system, since it's above 13, it's going to move down to the 0th floor. It's also going to move down another floor because the 13th floor was skipped. So this is a very Eurocentric view of buildings, which is fine. Okay, so I'm just going to say if n is less than, what should we say, less than 13, then return n minus 1. And I'm going to just see if I pass the first couple tests when I do that. And I do, then I fail the third test. And I'm going to say else return n minus 2. And let's see if that works. Okay. Now, I might be missing something. Sometimes I sort of mess up on very simple arithmetic. I'm going to hit attempt, and I think this is probably going to fail somewhere. Ah, okay. 0. That's cool. All right. So, should return a correct? Okay, so let me make a case for 0. If n is, let's just say, if n is 0, then return 0, I guess. Okay. So I'm passing that set of tests. Should return a correct value for basement floors. Oh, didn't, Basements stay the same. Okay, well, let's put another condition in here. If n is less than 0, return n. And then I can go through these elifs. So let's try that again. And it looks like I passed all the tests. Now, you know, this is something about, maybe says a little bit about test-driven development. If you have a set of tests that cover conditions, it's really helpful to kind of write your code in a way where you're passing them, passing a couple of them, then modify your code a little bit to pass more of them. This is a solution, and it's just a stack of if-else statements. So let's submit that. I'm sure there's a prettier solution. Oh, no. Oh, well, there is that. I could do if n is less than or equal to 0, return n. I didn't need to do 2 conditions on that, but either way. And then I'm back over here. I'm going to just refresh this. And here's kind of a common programming problem that you might see a lot. Is it a palindrome? So let's go ahead and work on this. So we're going to write a function called isPalindrome that checks if a given string, case insensitive, is a palindrome. So let's train this. And it's telling us something about the Racket programming language. And I'm just going to say that these challenges are kind of a mixed bag, sort of like programming problems in the real world, in that you're trying to figure out what you're doing, except in this case, you're trying to figure out what somebody's asking. This should be pretty straightforward. There's a list of palindromes down here, things that are palindromes like ABBA, and were KODOK, and other things like Walter, which are not. So if what we can say here is if trying to think of a good way to think about this that'll be quick to understand. Okay, so I'm gonna just break these out into lists. So let's consider the word ABBA or ABA. And if this is the same forward and in reverse, then it's a palindrome. So what I could do, this is S, right? I could say if S equals S, and I think I might be wrong about this. Let me see if this actually works. Then return true. Else, I usually don't write else's in these cases. I just, if it's at the end of a function, but I'm going to go ahead and do it here. Return false. So let's just see. Okay. Now, that does work, this syntax. So this is a, I'm saying, this syntax right here is reversing the string, right? So if the string is equal to the reversed version of the string, then let's return true. But notice in this case, where we have capital A, BBA, if we return this, like capital A is not the same as lowercase a. And I can go ahead and figure out some way to make sure that these are, that I'm not considering lowercase letters. So there's a method, a string method called .lower, and I'm just going to use that. So if s.lower equals the reverse of s.lower, then return true, else return false. Let's test that. And it passed all these tests. Let's attempt it. And it passed all of those. So if I click submit, then so here's an interesting solution. Well, I say interesting. I don't like this solution. I'll just be honest. because it modifies the parameter, right? We're overwriting the original parameter, and in general, that's something you want. Well, let's just say in general, it's something you want to avoid. Now, if this had a different letter, like P gets S dot lower, then P equals P reversed here, that would be better, I think. I don't think this is actually a good solution here at the top. Okay. All right, let's look at array madness. So given two integer arrays A, B, both of length greater than or equal to 1, create a program that returns true if the sum of the squares of each element in A is strictly greater than the sum of the cubes of each element in B. Oh. So if the sum of the squares here is greater than the sum of the cubes here, return true. All right. So this is, let's say, if, well, here's the thing. I'm going to go ahead and write something called the comprehension. But the thing is, if you're watching this, you probably don't know what a comprehension is. So let's do sum squares is going to get, and then I'll modify this toward being a comprehension. So sum of squares is going to get, oh, actually, this is going to be a for loop. I'm going to make a variable called sum of squares, and I'm going to set it to 0. This is called an accumulator pattern. I'm going to say for num in A, sum squares is going to get that number is going to be increased by that number squared. And I'm going to say sum cubes is going to get 0 also. Notice when I'm programming, I'm not always thinking linearly, or programming linearly. I'm jumping back and forth between places in the function. And you'll do this a lot as you become more and more proficient with coding. So for each number in B, I'm going to say sum cubes is going to get that number cubed. And then I'm going to say return is sum squares greater than the sum of cubes. And it says strictly greater, not greater than or equal to. If sum of squares is greater than sum of cubes, I think that should work. So that passed, and let's make an attempt. And that passed all the tests. Now, I'm going to condense this a little bit because I think there's a really nice way to write this. I'm going to say, let's return the sum of, this is going to be the same logic, but I'm using something called a list comprehension. And this is going to be num for, actually, it's going to be num squared for num in A. And it's the sum of that. And is that greater than num cubed for num in B? And let me go ahead and do that. And notice that that works as well. I think this is a better solution. It's nice to use comprehensions if you understand them. It's not necessary for you to know how to effectively use comprehensions for our program at this point. Okay. And interesting. Yeah, this is essentially the same solution. All right. Palindrome strings. This looks like another palindrome problem. but let's go ahead and solve it. Palindrome is a word, phrase number, which reads same backward as forward. This includes capital letters, punctuation, word dividers, and word dividers. Okay, implement a function that checks if something is a palindrome. Okay, so this might be more general. 1, 2, 3, 2, 1. 1, 2, 3, 4, 5, 6. Okay. I wonder if this includes capital. Okay. This is simpler than the last palindrome one we wrote. So return, let's say string, is this equal to string : -1? If these two things are the same, then this is going to evaluate to true. If this evaluates to true, it's going to return true. Let's see if that's the case. Oh. Int object is not subscriptable. Oh, interesting. Okay. Right. Okay, so if type of string, actually, I can do this even simpler. So I'm going to cast all these to string. And just in case, we're dealing with a number. Because we don't really care what these values are, right? What type they are. We don't care if they're strings or numbers. I'm going to go ahead and just cast them to string. And it passed those. Let's see if it passes everything else. It passed all the tests, and yeah, looks like everything's good. All right. So if you're watching this, you're probably, getting it. It's a pretty straightforward platform. And I'm going to just continue doing this probably for the next 15 minutes to half an hour. I might do some 7Q problems too, but in general, if you're fairly new to Python, I would say just do the 8s. And every time you find something that you don't know, continue studying your materials, and you're going to eventually come back to that problem, right? And that's kind of what this kata I have not completed thing is about. So yeah, let's do more. Okay, the wide-mouthed frog is particularly interested in the eating habits of other creatures. Can't stop asking the creatures what they like to eat. Alligators like to eat wide-mouthed frogs. It makes its mouth tiny when it meets the alligator, so that the alligator doesn't eat it, I guess. Your goal in this kata is to complete the mouth size method that takes one argument animal, which corresponds to the animal encountered by frog. Okay, well, let's just look at this. Okay, mouth size of the animal. If this one is an alligator, return small, otherwise return wide. Okay. I think it's just saying if, I'm just gonna say if animal isn't equal to alligator, then return wide, else return small. I think that's the logic they're looking for here. Yeah. So it shouldn't matter what kind of animal it is unless it's an alligator, because every animal is going to return wide except for alligators, where we want to return small. Oh. Okay. Return, okay. If animal, let's say dot lower, this is, if you notice the test we failed over here, should work for this this alligator version right here, where it's not all lowercase. Then yeah, let's just see if that works. Yeah, that passed. So pretty easy. Again, if you haven't seen, we haven't touched on strings in the course yet, but if you haven't seen this kind of approach, don't worry about it too much. This is more about, you know, getting a footing in the language, getting a sense of what we're doing here. All right. So I'm going to submit that, and let's go ahead and do some more. Who is going to pay for the wall? Let's take a look. This obviously has a political bent to it. Not going to talk about that at the moment, but okay. Wants to build a wall, trying to get the neighborhood association to pay for it. Okay. Your code will show a full name of the neighbor and the truncated version of the name as an array. If the number of the characters in the name is equal or less than 2, it will return an array containing only the name as is. Oh, see, this is the thing about CodeWars, is sometimes these are just kind of these nightmarish descriptions of problems. Yeah. Okay. Oh. Okay. I think it's just trying to get the first 2 letters of the string that's passed in. So let's try that. I think that's what it's asking. I'm gonna just take a little bit of a shot in the dark here. So if the length of the name is 2 is greater than or equal to 2, then return name let's try that. And I'm just taking a slice of the name, and elif let's just say if elif the length of the name is 1, then return the name, else return an empty string. Let's see if, I think that should work on the tests at least. Oh, I'm returning 2 things. Okay, I'm returning the list. Oops, let me zoom back in. I'm returning the original, sorry, not list. I'm returning a list with the original item, with the original string name. And, yeah, okay, I see. So, in this case, I'm returning, if it's length 1, it's only returning, all right. Yeah, this is just sort of some arbitrary rules, you know. All right, so if it's longer than 2, if name is longer than 2, then we return the name and we return the first 2 letters. If it's equal to 1, we just return the name. And otherwise, we just return an empty string. So I think that'll pass those tests. Oh. Huh. Interesting. Okay. How about this? Greater than 2, we add another elif. elif the length of the name is 2, or the length of the name is 1, then we return the name in a list form. So let's look at that. We pass all the base tests. Let's look at the extended tests. And it looks like we passed that too. Okay, so, you know, not all of these are great. And that's part of the thing about CodeWars, is that you're gonna have these like problems that are just maybe not that helpful sometimes. Like this is, you're kind of just figuring out what they're asking. And if I look at this, it's not entirely clear to me that this is what they're asking. And often I'm going through the tests. I'm trying to figure out what they're asking by going through the tests. So submitting that. And there's this nice little lambda function here. That's a great solution, but not necessary. You know, we're just using some if-else statements. Okay. Cool. Determine offspring sex based on genes XX and XY chromosomes. So let's look at this. Male gametes or sperm cells in humans and other mammals are heterogametic and contain one of two types of sex chromosomes. They are either X or Y. The female gametes contain only the X sex chromosome and are homogametic. The sperm cell determines the, determine if the sex of the offspring will be male or female based on the X or Y chromosome present in the male sperm. If the sperm contains the X chromosome, congratulations, you're going to have a daughter. Sperm contains the Y chromosome. Okay. So, this is pretty straightforward, right? This is this big long question, and turns out that if it's XY, it's going to return you're going to have a son. If it's XX, it's returning you're going to have a daughter. I'm just going to copy these strings directly. And I'm going to say if sperm is XY, and then I'm just going to say else. And I don't know why. Oh, because I have to return it. Return that. And return that. And I'm not entirely sure where there's an error here. Sometimes this will happen where you have to back up to here. Huh. Oh, that's why. All right. If you mess up tabbing in Python, sometimes you just want to like delete this whole thing and, you know, tab back in again, you know. All right, so I'm gonna hit test, see if that works. Looks like it worked. And under attempt, looks like there were only 2 tests under the attempt. So that's not amazing. Usually there's a bunch of tests, but you know, what are you gonna do? And go ahead and do this. So those are all 8Q problems. They're pretty easy. And I'm gonna switch over to doing 7Q problems. And these will be a little bit more difficult. So I might, you know, a couple of these might take a little bit longer. What I find generally is that 7 and 8Q problems are kind of the same. They're not that difficult, or not that different in difficulty. Oh, I think I remember this one might not actually, this one has a Python issue. And if something does have an issue, there's this one issue reported, let's say. This is probably going to say that it has some Python issue. Yeah. Okay. Yeah, this is not solvable through its... you can hard code a solution to this, but this coupon code one, and that's going to happen sometimes. These are all publicly made, community made, and with that in mind, you're going to find some that are not solvable. Kind of just turns out that that's the case. All right, so we'll do this other one, alternate capitalization. We're going to capitalize every other letter. And let's go ahead and do that. So A, B, C, D, E, F is going to be capital A, B, capital C, D, capital E, F. And let's go ahead and do this. So I think there's an automatic way to alternate capitalization. There's some string method that does that, but I'm not going to do it that way. I'm going to make a new string, and I can just do this, and I'm going to overwrite this string with letters from the string. So I'm going to say for letter in S, new string is going to get that letter. So this isn't going to work in its current form, but I'm just sort of building the template, and I'm going to test it, and I'm going to get a bunch of incorrect results. So notice I'm just building a new string. And what I can do here, it looks like the first letter should be capital, the second... Oh, interesting. Notice these tests. I'm actually returning two different versions of this. The one with capitals, it starting with capitals, and the other with it starting with lowercase. So new string, let's say, starts with capital, and then let's make another one, new string starts with lowercase. And I'm going to just enumerate this. For index and letter in enumerate, this is going to give me numeric values for every letter position in string. New string capital, let's say if the index modulo 2 is 0. I could write that logic a little different, I just want to be explicit. If that index modulo 2 is 0, then let's go ahead and build new string capital is going to get the letter to the uppercase. So I'm just uppercasing the letter and appending it on, and new string low is just going to get the letter itself. So and then else, and I'll just take these same things and I'll just swap the upper. So this is saying that if it's an even letter, right, like 0 is an even letter here, then then the capital new string capital is going to get the uppered letter, the uppercase letter, like that, and the lower string, new string lower, is going to get a lowercase letter. And then I want to return both of these. So why don't I do this? I want to return them in a list. I'm not sure why in a list, but that's okay. We'll start with new string capital, and then we'll do new string lower, and I think that should work. So it passes all of the built-in tests, and let's see if it passes everything else. And it looks like it does. Okay. So there probably is a way, probably a number of ways to rewrite this to be a little bit, I can think of a one-line solution for this, but I kind of just don't want to write it. Oh, you know what? I'll just do it. Yeah. Yeah. Okay. I'm just going to write it. Let's see. This is one of those horrendous things that you should never do, probably. Let's say letter. Oh, you know what? I just, you know, I'm just not gonna do it. I think I'm good. All right. And oh, that's kind of nice. Anyway, yeah. So this is, you know, this is just kind of a tour, and I'm gonna wrap it up here. This is a relatively short stream. Usually, I'll stream for about an hour to 2 hours, depending on the problem or depending on the thing that I'm working on. Next time, the thing that I'm going to code up, I'm gonna just find a quick image of it. I'm gonna code up a fusion between RGB and RGB and thermal images, and it's going to end up looking something a little bit like Predator-ish, maybe the way Predator sees things. And we can think about this in terms of really all kinds of visual problems, right? And if you can imagine having a pair of glasses that you know, sort of takes an image in the outer world and frame by frame feeds you a thermal / RGB image, you'd be able to see, let's say, heat signatures of squirrels in trees, or there's an obvious military application. I don't really want to think about it in those terms, but there would be that. And let me just find something that will show what I'm talking about. So there's an image data set called the cased data set, and here's an image. It's all paired. It's paired images. So there's a color image, and I'll show you a thermal image that is paired with that. And this is a publicly available data set, KAIST, and I'm going to be working on this next time. So what I'm going to end up with is some fusion of these two, and there's a number of options there, but I'll just show you what I think is the best option. And I'm replacing sort of an arbitrary, a standardized version of light with the actual thermal. And if you can see this clearly, it may not be that clear, but I'll make it a little bit bigger. Looking at this, humans, engines, lights, anything that has like a strong thermal signature is coming through, but we're also getting some color values in there too. And so arguably the most important thing here, let's say if you have a pedestrian detection system for a self-driving car, the emergency, say, cameras that would tell you, oh no, there's a person in front of us that maybe we didn't see, or something like that, something that the LiDAR didn't pick up. You know, what you end up seeing is very detectable humans and other detectable heat type of objects. So, you know, this is what I'm going to do next time. Today was just CodeWars because I think it'll benefit some people. And if you have any questions on CodeWars, reach out to me on Slack or post a comment here. And hopefully this will be helpful to people who are trying to get their footing in Python. You need to do a lot of repetition, and CodeWars is great for that. Other options, just I'll throw these out there. HackerRank. HackerRank is really good. And I don't really use it, but you know, it's there, and I think it works really well. And some of my friends are really into it. So this is another one. I think CodeWars is fun, sort of because it's messy, and some of the problems are hard to figure out what they're even asking for, which I think is actually a good thing for practice. Okay, thanks so much. My name is Tovio Roberts. Tune in next Thursday, 3 p.m. Mountain Time. I'm going to be doing, something maybe more data science-y